Hi, let us have a quick overview on the service mesh and the role being played by Istio. As you all know, the microservices is getting very popular because of its flexibility in terms of scalability and very high availability. And whenever I am deploying the microservices, I may have n number of microservices getting deployed, and each microservices know what is the next microservice it needs to call to get the required data. Let us consider a small application where it's going to have three type of microservices: microservice A, microservice B, and microservice C. Microservice B going to be there in three numbers for scalability, where the load from A will get distributed to all these three instances of microservices B. And B in turn going to use the microservice C, and that's going to be there in count of 2. Now let's assume I'm going to have a functionality addition for microservice C, and I am building another version C1. Whenever I am deploying this particular C1, I need to update the microservice B saying a new version of microservice C is available, and that is C1, and how to identify and how to make the call. So the change that I made as a part of microservice C is impacting the working of microservice B. This should not be there, as each microservice should be independent of each other. And I may have some requirement where I do not want to deploy the entire version of microservice C1, and I want to route only a percentage of the request to C1 and the remaining to the older version, like a canary deployment. Example, I may want to deploy only 10% of the request to C1, and the remaining 90% should get routed to C as it is. And if everything is fine, I may start routing all the requests to C1 from the microservice B. To do all these changes and control, I may need to make the changes to the microservice B, and that will be very difficult in production scenario when I have thousands of microservices. And I need an environment to control these type of scenarios. The scenario I have explained is very simple and basic requirement. Like this, there are n number of scenarios and problem statements available that needs to be addressed. That's where the service mesh comes into picture. I'm going to provide additional information about service mesh using some analogy. Let's assume I do have 3 managers, and each manager going to have a PA. Let's assume this is CEO, this is CFO, and sales head. Any communication being made to the CEO or from the CEO, it will be routed through the personal assistant. So the personal assistant knows to whom to communicate and how to take the message to the corresponding person. Let's assume CEO wants to send some information to CFO, and CEO will send the message to the PA, and the PA of CFO will receive the message, and the PA will forward the message to the CFO. And CEO doesn't need to know who is the sales head or who is the CFO. Directly the message will be handled by the PA. The same way, in case if any message needs to be sent to the sales head from the CEO, the message will be forwarded to the PA, and PA will forward the message to the corresponding PA of sales head, and they will forward the message to the sales head. The actual managers doesn't need to know how to send the message, to whom to send the message, when to send the message. So all that will be handled by the PA. Now for some reason, there's going to be a transition of the sales head. A new sales head going to come into picture, and a few of the projects being handled by the new sales head. And any message being sent to the PA will take care of what message to be sent to the backup sales head and what message to be sent to the actual sales head, depending on the work distribution. After the time limit gets over, the actual sales head will get released, and all the message will get routed to the new sales head, and that will be taken care by the PA. So all this transition doesn't need to be published or need to be known by any other managers, and the same thing is true with the external visitors as well. So if any new visitor coming in, the first point of contact will be the PA. Now let me rename these entities. So this is going to be the pod, and all the communication to the pod will be handled by the sidecar. It's also called as proxy. In Istio case, we will be using envoy. So I can represent that as a sidecar, proxy, or envoy. I can have another layer of components which can control all this proxy. Let's say I'm going to have a layer of entity. We call that as Istio D. That's going to have a number of components like pilot, citadel, and galley. After Istio version 1.5, all these three components have been merged and made as a single component called Istio D. Whenever I am installing Istio as a part of Kubernetes, I will be having one single component called Istio D that's going to have all the functionalities of pilot, citadel, and galley. While discussing about the Istio architecture, we will have detailed discussion about the roles and responsibility of these components. Now all these components together, that's going to manage this sidecar. So from a centralized location, I will be having control on this particular sidecar on what to do, what not to do, and how to do. And this is what we call it as the data plane. So all this together, we call that as data plane. And the one that's going to control all the sidecar, we call that as a control plane. Slowly, I'm going to introduce the terminologies one after the other. Don't worry about the internal architecture and the functionalities. We are going to have detailed discussion about each and every component in the future lectures. So don't worry. This is a very high level overview to get a feel on what is Istio and how it's going to play its role and what are all its responsibility. So on a high level, if I get into the Kubernetes, every pod that's going to have the actual container that's going to do its responsibility, and Istio will inject a proxy or a sidecar to each and every pod that is getting created within the namespace where I have enabled the Istio. So the keyword that we need to observe very carefully is what are all the namespace where the Istio needs to be enabled. And that will be enabled by adding a label to that particular namespace saying any pod that is getting created within that namespace should have this particular sidecar. And the sidecar will be handled by the proxy that's called envoy. So this is the proxy Istio will be using. I can go ahead and use other proxies, but this is a very popular one that's made to do the actual job of proxy within the service mesh. And to achieve this particular requirement, Istio was created keeping in mind these three responsibilities, that is traffic management, security, and observability. Without making the code change into the actual application, I will be in a position to make the configuration change within the proxy controlled by the Istio and do all these jobs and responsibilities like traffic management, security, and observability. This particular course, we are going to have detailed discussion on each and every activity within these tasks with a demo. So in a quick summary, we had an overview on what is a service mesh and its roles and responsibilities, how Istio fits into that particular space of a service mesh.